I've been playing around in SketchUp designing a router table around the Incra LS Super System router table fence. Not wanting to let all that real estate behind the fence go to waste, and having viewed various bench tops and jigs that make use of the MicroJig MatchFit dovetail clamping system, I thought that would be the perfect candidate for this project. But I was a little leery of the strength of the system, whether it would hold up to use, especially with a tabletop made from 2 layers of MDF with a laminate overlay. So I decided to run a series of tests. Oh yeah, disclaimer. I have no connection with the MicroJig company. I bought my own MatchFit clamps. MicroJig has not endorsed my testing or this video. In fact, as far as I know, they don't even know about it. Halfway through my testing, I found that someone else had beaten me to it. I strongly recommend that you watch Jesse's video before watching the rest of mine. My tests are a little different and expand upon his conclusions. I conducted the tests on scrap chunks of 3/4 inch MDF, both plain and with laminate, 3/4 inch plain birch ply, and a chunk of 5/4 oak. I expected the MDF and plywood to have reasonably similar responses, both with and across any grain, but I tested the oak in both directions. In the first test, I tightened a single clamp against a short chunk of old 2x6 with as much torque as I could muster using just my hands. According to the MicroJig website, the clamp can exert almost 600 pounds of force. The force imposed by the clamp arm wedged in the slot has both a vertical component and a horizontal component. The vertical component is matched in the other direction by the force of the board chunk pressing down. This prevents any ripping out of the slot itself. The horizontal component of the force acts to compress the base material. Naturally, some materials resist this compression better than others. I could feel that in the MDF, as tightening of the clamp seemed to take more turns, as apparently the clamp arm rode higher in the slot as the MDF was compressed. In all cases, when I loosened the clamp, I had to use a mallet to whap it down in the slot before I could remove it. I expected to see some damage to the slots, but there was none apparent in any material. The scrap of 2x6 did show some damage, though. The clamp pad pressed as much as 14/1000ths of an inch into the wood. Note that the indentation was not symmetrical across the face of the pad. This surprised me, as the pad is on a ball swivel. On to the more interesting but not really very relevant test. I clamped a 34-inch long 1x3 so that the clamp pad was centered 2 inches from the end of the board, then applied upward pressure to the other end until something gave. Theoretically, the law of levers says that if I apply 10 pounds of upward force at the end of the board, that's the same as applying 170 pounds of force at the clamp pad. Since the back end of the clamp is restrained by the end of the board, the clamp should then pivot up through the slot, destroying it. Unless, of course, the slot material successfully resists that force. The clamps, as I expected, were strong enough to come through the test with flying colors. The slot material didn't, however. The plain MDF started to delaminate at about 6.5 pounds of force at the end of the lever, or 110 pounds at the clamp, and at 7 pounds slowly gave way. The laminated MDF fared only slightly better, starting to split at 7 pounds. As you can see, the layer of laminate had the effect of spreading the load, so that the failure was not quite so localized. The birch ply resisted a little more force, starting to separate at 9 pounds. It was also a slow failure, until the entire square to the right of the clamp popped off. Damage on the left side was limited to about 1.5 inches from the clamp line. The piece of oak provided the most interesting results. As you can see, I made a mess of the groove I routed along the grain. I did it backwards, resulting in an ugly climb cut. That gave me the chance to do 2 tests, one on the sloppy groove and one on a good one. First, the sloppy one. As Jesse found, the along the grain slot did not resist the force, although it took considerably more pressure, 22.5 pounds, to induce failure. In comparison to the MDF and plywood, the failure was abrupt. The nice groove, surprisingly, didn't perform much better. The connection started feeling mushy at about 18 pounds of pressure. and suddenly gave way at about 23 pounds. I think that the grain of the wood plays a large part in the strength of the slot at this orientation. The cross-grain test is the one that Jesse skipped, and as expected it proved much more durable. I got up to 27 pounds of upward pressure on the end of the board before I got uncomfortable watching the clamp distort. I didn't really want to destroy it. As you can see, when I removed the lever, the groove looked absolutely pristine. Even a head-on shot shows no apparent damage. And as you can see, the clamp itself sustained no discernible damage. Given my findings, what would I do differently on the router table? Well, I think any of the materials would be satisfactory for the top. Since bare plywood was roughly 40% more resistant to being damaged in the lever test, I might consider replacing the 2 layers of MDF with birch ply. And, to forestall warping, the bottom should also be laminated, or at least coated with a layer or 2 of polyurethane. But would the birch ply give as flat a surface as the MDF? For a really bulletproof top, use a chunk of maple countertop at least 1.5 inches thick, with the grain running crosswise of the way I'm most likely to use the clamps. But not butcher block, since the vertical grain may be weak in this scenario. And no matter which way I go on the top, if I'm going to have a vertical MatchFit board, make it also from hardwood, as there's more likelihood of along the board force, both from working the wood and from accidentally bumping the clamps. Thanks for watching. Now, why don't you go do something useful?